Hi all, today I'll show you how to resolve sign ambiguity when using Napier's rules. Now for those of you who don't know what sign ambiguity is, I'll explain it in the question, but just a quick explanation before we start. Sign ambiguity means that you may get more than one correct answer, and at that point of time you are not sure which is the correct answer. So how to determine which would be the correct answer? Both answers may seem to be the correct answer, but I'll show you how to determine which is the correct answer, and this is called the sign ambiguity because this occurs when you use the inverse of sine to find out the value of an angle. So you press shift sine inverse in the calculator and you get one value, but there could be another value which may be the correct answer as well, and that is when you have an ambiguity. Ambiguity means you have a doubt. This question will also involve a quadrantal spherical triangle. So a quadrantal spherical triangle is one in which the side of a triangle is equal to 90 degree. Not an angle, but a side of a triangle is equal to 90 degree. So let's get started with the question, and in the middle of the question you will see the sign ambiguity will occur, and at that point of time I'll show you how to resolve it. So the question is that in triangle PZX, side P is equal to 90 degrees, angle P is equal to 48 degrees, and side Z is equal to 120 degrees. Alright, so what I'll do is I will distinguish the side from the angles by writing the sides in smaller letters like P and angles in capital letters. So what I will do is I will write the sides in smaller letters and angle in capital letters. So you can see the triangle is drawn here, and here side P is equal to 90 degrees. The angle opposite to side P is capital P, right? So I've written it in different ways so that you don't get confused. Then we have side Z equals 120 degrees, and you have the angle Z written as the capital letter, and then we have side X. I've written X like this here to denote it as a side, and the angle X opposite to it as a capital X. Alright, so make sure you distinguish it. Sometimes if you write both the letters similarly, you might get confused. Once you have drawn the triangle and you have labeled the parts, now you have to find out the rest of the parts. That's the question. So you have to calculate the value of all the other parts. That's the question. So you start by drawing the Napier's diagram. This is how the Napier's diagram is drawn. So the Napier's diagram is drawn by drawing a circle. Divide the top semicircle into 2 halves and bottom semicircle in 3 halves. Then the first thing that you do, and again I can show it to you, you draw a circle, divide it into 2 semicircles. The top semicircle divide it into 2 parts, and the bottom semicircle divide it into 3 parts. And the first thing that you do is you write the 90 degree side outside the circle. So P equals 90 degree. Write it outside the circle. Side P equals 90 degree. Alright. Then write the angles that are next to it. What are the angles that are next to the side P? It's Z and it's X. You can write it in any order in the top semicircle, but once you write it, then you should maintain this order. So you write Z and X, which are the angles next to the side P. Then write the side opposite to Z. What is the side opposite to that Z? Write it opposite to Z here. You write it here, and always prefix it with 90 minus. So the side opposite to Z is side Z. So you will write 90 minus Z. The side opposite to angle X is small x. So write 90 minus X here. So whatever you write in the bottom semicircle will be prefixed by 90 minus. Always write 90 minus and then write what you have to. And then write the remaining side which is left. What is the remaining side? What is the remaining angle rather that is left? Is 90 minus angle P. That is the remaining angle. So that's how you draw the Napier's diagram. Write the 90 degree side outside, and then the angles next to it, and then once you write the angles, write the sides opposite to the angles, and then of course the remaining angle. This is for quadrantal triangles. Quadrantal triangles are those triangles where the side is 90 degree. Right angle spherical triangles are those triangles where the angle is 90 degree. I have already made one video. The link is in the description section for right angle spherical triangle as well as quadrantal triangle. This is example 2, and I'll put up more examples in future for you to be able to practice. So once you have made the Napier's diagram, write down the values that you already have and take them, and then find out the values that you don't have. Alright, so always use the values which are given to you in the question to find the rest of the values. Don't use the value that you have just found out from your calculation to find out the rest of the values, because if there is a error, then you will be carrying that error forward. That's why we avoid doing that. We always try to use the values which are given to us to find out the rest of the values. So the first thing I'll be doing is finding out the value of side x, which is unknown to me. So to find out the side x, I have to use one of the two Napier's rules. So the Napier's rule is sine of middle part equals tan of adjacent parts, or product of tan of adjacent parts. Alright, I'll explain to you what it means. And the other rule is sine of middle part equals cos of the opposite parts. Alright, so you have to use one of the two rules. Now when you're trying to find out the value of side x using the values which are given to you, you have to form an equation where all three are involved. So you have to think about it. Will the first rule apply or will the second rule apply? Now the second rule cannot apply, because if you choose any of these values as mid part, then one of the other gets omitted. So if I say I will choose 90 minus p as sine of middle part, and then cos of opposites will become z and x, which is not what I need. So I will use the first rule here, and I have to make sure that all three of them are involved and it forms a mushroom shape. So all three of them involved in this equation here, where sine of 90 minus p, which is the middle part, equals tan of the adjacents, tan 90 minus x multiplied by tan 90 minus side z. Alright, so I'll call it z or z depending on what you want. That's the equation. Now with quadrantal triangles, when you are solving quadrantal triangles, remember this rule is only for quadrantal triangles. If you form the initial equation, alright, when you form the initial equation, which is this equation here, if you see that on your right hand side both of them are sides or both of them are angles, so here you can see both of them are sides, side x and side z. When both of them are sides or both of them are angles, you will introduce a negative sign on the right hand side, an additional negative sign. This is what I have done. I have introduced a negative sign on the right hand side of the equation. Alright, so because both are sides in the initial equation. Now sine 90 minus p also equals to cos p. That is the rule. Sine 90 minus p also equals to cos p. So sine of 90 minus any angle that we'll call theta, 90 minus theta equals cos of theta. Cos of 90 minus theta is always equal to sine theta. And I'll tell you what is the rule with tan as well. So tan 90 minus theta equals cot theta, which is nothing but 1 by tan theta. We'll talk about that later. So sine of 90 minus p equals cos p. We have the extra negative sign, and then we have tan 90 minus x and tan 90 minus z on the right hand side. Now p's value is given to us, so this becomes cos of 48, which is equal to, with an extra negative sign, tan 90 minus x, which is unknown to us, and tan 90 minus 120 degrees, which is side z. So what we do is we keep our unknown on one side and take our knowns to the other side. So this equation becomes tan 90 minus x equals, we keep the negative sign on the right hand side, cos of 48 divided by tan 90 minus 120. This also becomes, and keep the negative sign, alright, till you resolve it in the end. Negative sign is here as well. So again, this is cos of 48, and like I said, tan of 90 minus theta equals to cot theta. But cot theta is nothing but 1 by tan theta. And this is the rule that will apply here. So tan 90 minus 20 equals to cot 120. But cot 120 equals 1 upon tan 120. Alright, this is to simplify it for your calculators. So this equation here becomes cos 48 divided by 1 by tan 120. 120 goes up. So this equation becomes minus cos of 48, minus sign is still there, the extra negative sign that we've included, multiplied by tan of 120 divided by 1. 1 is insignificant in this equation, so this becomes equal to cos of 48 multiplied by tan 120. Still the negative sign is there. Find out the values of cos 48 and tan 120 from the calculator. So tan 120 is negative 1 minus 1.73205. Cos 48 is positive 0.66913. But because we have a negative sign here, when we multiply these two values together, we get minus 1.15897. But minus and minus becomes positive. So this will become positive. And this becomes tan of 90 minus x equals positive plus 1.15897. Take tan to the other side, becomes tan inverse. Find out the value of the tan inverse. So this becomes 90 minus x equals tan inverse of the value. Then 90 minus x equals 49 degrees 12.7 minutes. So tan inverse of 1.15897 is 49 degrees 12.7 minutes. Then of course we keep x on one side, or we can take x to the other side here and bring 49 here. So x becomes positive, 49 becomes negative. So 90 minus 49 degrees 12.7 will give you 40 degrees 47.3 minutes. That is the answer of side x. Now sign ambiguity has not occurred here yet. I'll show you when the sign ambiguity will occur. Alright, that happens with the sign values. So the next thing we'll do is find out the value of angle z, angle z here. Alright, so the angle z we need to find out by using the values which are given to us. So I'll get rid of this. So to find out angle z using the values which are given to us, what equation can we form so that we can involve all three of them and include a Napier's rule as well? So here if we want to include the two values which are given to us and the one that is not, that is angle z, we will use the second Napier's rule, which is sine of middle part equals cos of the opposites. So sine of middle part becomes z, becomes the sine of middle part, angle z, and the other two values which are given to us becomes the opposites. So that results in the equation sine of z, angle z, equals cos of 90 minus z and cos of 90 minus p. Now remember I told you in quadrantal triangles, if in the initial equation both are sides or both are angles on the right hand side, you will introduce a negative sign. But here one of them is a side, which is side z, and the other is an angle, which is angle p. So you don't have to introduce the negative sign. So sine z, it will be equal to sine of z, because cos of 90 minus z is equal to sine z, and cos of 90 minus p equals sine p. This is something I have explained to you earlier. So put in the values of z and p in the equation. So sine of z equals sine of 120 multiplied by sine of 48. Find out the values of sine 120 and sine 48. Both are positive values, and what you eventually get is sine of z equals 0.64358. Take sine to the other side, becomes sine inverse, and sine inverse of this value gives you the value of angle z as 40 degrees 3.6. Now when you find out the angle z value here of 40 degrees 3.6, there is a sign ambiguity here. Now why is there a sign ambiguity? Now when it comes to spherical triangle, you have to remember that there is a rule associated with it. Alright, so the rule here is that you can see here is that if the value of the side is more than 90 degrees, the value of the angle will also be more than 90 degrees. Alright, so that is the rule that goes with the spherical triangles. So you have to be always be very mindful of what your values of the sides and the corresponding angles are. So when you see that you have found out the value of the angles corresponding to the side, you have to ask yourself that is that correct value or is that incorrect value, because you have to see that the side value here is more than 90 degrees, right? So your corresponding angle value should also be more than 90 degrees. If it is not, then you should say that there is a ambiguity that is occurring here, because if my side value is more than 90 degree, why is my angle value coming less than 90 degree? Alright, so that is the rule with the spherical triangles. So if you want to know more about the rules of the spherical triangles, I have made videos on that as well, and you can follow that video. The link is in the description section below, and you can follow it and you can learn from it. Alright, so any angle and its opposite side in the Napier's rules spherical triangle are of the same affection. So if any angle is less than 90 degree, the opposite side will be less than 90, or rather if any angle is more than 90 degree, then the opposite side will also be more than 90 degree. So here side Z is 120 degree, so angle Z cannot be 40 degrees 3.6, it also has to be more than 90 degrees, and this is where the sign ambiguity will occur. So to find out what is the correct answer, what you will do is, whatever you have found out, you will subtract it from 180 degrees. So 180 degrees minus 40 degrees 3.6 will give you 139 degrees 56.4 minutes. Got it? And that is the correct answer, value of angle Z. And here you can see is that angle Z value becomes more than 90 degrees. This is more than 90 degrees, so this must be the correct value. So although both values are positive, you have to choose any one value as the correct answer, and you choose this value because the value of the side Z was more than 90 degrees. So this is the example of sign ambiguity. Finally, we will calculate the value of angle X using the values that we already have. So I will get rid of the last triangle that we made, and this time I will ask you to make the equation. So if you have to make an equation where you have to involve angle X and the values that are known to us so that it forms a mushroom shape, what will be the rule? Will you use rule 1 where sine of mid part equals tan of adjacents, or will you use rule 2 sine of mid part equals cos of opposite? Pause the video here, make your rule, and then start watching the video so that you know what is the correct answer. Alright, try to make up your own rule, not your own rule, but choose the right rule. Alright, so pause the video, and now if you are starting again, the rule will be sine of mid part will be this one, 90 minus Z, and tan of adjacents will be angle X and tan 90 minus P. Remember, the unknown doesn't always have to be the mid part. It can be any of the parts of the equation. The important thing is to include the two that you know and the one that you don't know in one equation. The unknown does not have to be always part of the mid part. It doesn't have to be the mid part. Alright, so here the equation becomes sine of 90 minus Z equals tan X and tan 90 minus P. Now again, because on the right hand side both are angles, I have introduced a negative sign. You will introduce an extra negative sign on the right hand side of the equation. Also, sine 90 minus Z is equal to cos Z. As I have explained before, sine 90 minus theta equals to cos theta, and tan 90 minus P equals cot P. So again here we have tan X as the unknown, so we'll keep the unknown on one side, take the knowns to the other side, and I'll continue the negative sign with the knowns. So this equation becomes tan of X equals minus cos Z. So minus is the extra negative sign I've included because both of them were angles, divided by cot P. But cot P also equals 1 upon tan P. So then tan P goes on top here, and this equation becomes minus cos Z multiplied by tan P divided by 1. 1 is insignificant now in this equation, so this equation becomes minus of cos Z multiplied by tan P. Put the values of the values that you know. So cos 120 multiplied by tan 48, cos 120 is minus 0.5, and tan 48 value you can see here that it's positive. Negative and negative will become positive, so you get a positive value here, right? So once you form it in the equation or you put it in the calculator, you will get tan Z equals 0.55531. Take tan to the other side, becomes tan inverse. Tan inverse of this value will give you 29 degrees 2.6 minutes. In your calculator you might get 29 degrees 2 minutes 37.9 seconds. So to convert 37.9 into decimal of a minute, divided by 60, and it will be 0.6. Add 0.6 to the minute here to get your answer in degrees and minutes. There is no problem in writing answers in seconds, but when you are solving, say, questions that involve great circle sailing and composite great circle sailing, then you cannot write the values of, say, distances and angles in seconds. You can only write them in degrees and minutes. That's why I don't really encourage people to write the values in seconds. Always convert it into degrees and decimals of a minute. So guys, I hope this video was useful to you and you understood how to not only solve a quadrantal triangle, the extra negative sign, when to introduce it, but also to resolve the sign ambiguity if it occurs. So always keep checking when sign ambiguity may occur, especially with respect to the corresponding angle or side value. Thanks guys, and thanks for watching, and let me know what you thought about this video.